In this class, we're going to go over questions on the chain rule of differential calculus. What exactly do we mean by chain rule? When do we use chain rule to differentiate a function? What type of function do we use chain rule to differentiate? In an attempt to explain this concept, the chain rule of differential calculus is also known as the function of a function. You understand? Now, if you are asked to differentiate a function that has another function in itself, don't worry, let's look at some example. Let's say we are told to differentiate this function y equals to x plus 1 squared. You understand? Now, if you look at this function, I'm very sure if you are part of our previous class, and I know that you can easily expand this function and take the derivative. Now, but what of in the case if the power is like is 10? You cannot expand that kind of function. You understand? It is best to use the chain rule. You understand? Now, chain rule is used to differentiate a function that has another function in itself. If you look at this function, y equals to x plus 1 raised to the power of 2. X plus 1 is the inner function. You understand? And y equals to x plus 1 raised to the power of 2 is the outer function. Now, to differentiate this function, the first step is that you have to set the inner function equals to a letter. You understand? The basic formula for chain rule is this: dy all over dx is equals to dy all over du multiplied by du all over dx. You understand? Just pay attention. This is the basic formula for chain rule. Now, in this case, I'm going to set the inner function equals to a letter. The function inside the bracket is known as the inner function. So I'm going to set u equals to x plus 1, which is the inner function. That means that if u equals to x plus 1, that means that y will be equals to what? U raised to the power of 2, because I have already said let u equals to x plus 1, okay? Now, the next step is that you have to take the derivative of both u and y. So, the derivative of u is what? Du all over dx. Du all over dx will give us 1. So, the derivative of u is 1. Now, we need the derivative of dy and du. Dy all over du will be 2u raised to the power of 2 minus 1, which is what? 1. Okay? Now, having differentiate both, we can proceed to use the chain rule formula. What does it say? Chain rule formula says that dy all over dx is equals to dy all over du multiplied by du all over dx. Here, dy du is 2u, so I'm going to have 2u multiplied by du over dx. Du over dx is 1, so I'm going to have 2u multiplied by 1. Here, I'm going to have 2u. Now, recall that, don't forget that u equals to what? X plus 1. So, I'm going to replace u as x plus 1. So, dy all over dx is equals to 2 into bracket x plus 1. Dy all over dx is equals to 2x plus 2, which is the solution to that differential, to the derivative of y equals to x plus 1. Now, you can see that this is a bit simple. Let's have a more complex example compared to the first one. Let's say you are asked to differentiate y equals to 2x plus 1 raised to the power of 10. Y equals to 2x plus 1 raised to the power of 10. Now, you can see that you cannot easily expand this. So, the best approach is to use the chain rule formula. Okay? How do you use the chain rule formula to differentiate this? The first step is that just set the inner function equals to a letter. In this case, we are going to be making use of u. You understand? Set the inner function equals to u. So, I'm going to have u equals to 2x plus 1. Then, in that case, I'm going to have y will be equals to u raised to the power of 10. You understand? Because if u equals to 2x plus 1, that means that y equals to 2x plus 1, which is u raised to the power of the 10. So, in this case, let us take the derivative of both u and y. The derivative of u will be du over dx equals to 2, and dy all over du equals to 10u raised to the power of 9. Now, having done that, the next step is to proceed to use the formula. The formula for chain rule is dy over du multiplied by du all over dx. So, dy all over dx is equals to dy over du. Dy du is 10u raised to the power of 9 multiplied by du over dx, which is 2. Here, I'm going to have dy over dx is equals to 10u raised to the power of 9 multiplied by 2 will give me 20u raised to the power of 9. 20u raised to the power of 9. So dy all over dx is equals to 20u. U is what? U is 2x plus 1. So replace it. We are going to have 2x plus 1 raised to the power of 9. So the derivative of y equals to 2x plus 1 is 20 multiplied by 2x plus 1 raised to the power of 9. You can see now. Okay, so let's have one more example. Let's say we are asked to differentiate this function. You can also try it by yourself. Just attempt it. Okay, 2x plus 1. Okay, no, don't let us use 2x plus 1. Just attempt this. Differentiate y equals to 2x plus 4 raised to the power of 3. What's your answer? And drop your answer in the comment section, okay?